Today we shall discuss a new topic called as extended surfaces. We know that basically there are three modes of heat transfer, the study of which is already done. If you remember, we have got three modes. One is called as convection, and radiation heat transfer. Okay, when we say convection, it is already known to us that convection is a mode of heat transfer that occurs between a surface and a fluid. Okay, let me draw a diagram for that. Okay, so there is a surface like this. Let us say it is a hot surface, okay, whose temperature is maintained, say at a temperature Tw, which is uniformly maintained over this surface. Then surrounding this surface, let us say onto this face of the surface there is a flow of air like this, whose temperature, let us say it is T infinity. Okay, so because of this temperature gradient, knowing that Tw is greater than T infinity, so as the air starts flowing over this surface, this face of the surface, okay, where the temperature is Tw, air is having a temperature T infinity, then we will see that convection mode of heat transfer occurs, depending on whether the air is forcibly made to flow over it or naturally made to flow over it. Accordingly, we say the convection is free convection or forced convection. But in all, the convection heat transfer occurs between this surface and this air, as a result of which heat flows from the hot surface to the air. Okay, so the amount of heat that gets transferred, to the air as it flows over the surface is given by Newton's law of cooling, which is known that Q is equal to H into A into delta T. Okay, so where H is called as heat transfer coefficient, okay, then E is surface area, and this delta T is temperature difference. Okay, so this Q will be having unit watts. Okay, now let's suppose, I'll come back to this diagram. So I want to increase the rate of heat transfer Q from the surface to the air. Okay, so this parameter Q I want to increase. Okay, so for increasing the rate of heat transfer Q, so from this formula it is very clear, with the known temperature difference, this is fixed, okay, and the heat transfer coefficient, either have to increase it as well as this E, this has to be increased. So in Newton's law of cooling, it is only known that to increase the value of Q, either you have to increase the value of H or you have to increase the value of area. So it is already known to us that for between a surface and a flowing fluid, the H is always constant. We can say it is constant. So if the fluid is air, the H value between the surface and the air will be generally minimum. It will be very less. Okay, so we want this value to be increased. It is practically possible to increase the value of H by increasing the velocity of the air. Okay, but it is not sure that you can increase it for a larger value. Okay, so there is some limitation for this value of H. Okay, so you can increase only up to certain point by increasing the properties, by increasing the surface roughness, the surface finish of the surface, as well as by increasing the velocity we can increase the value of H. Okay, but there is a limitation for this. So this is also having some limitations, and this delta t here for the given example, it is Tw minus T infinity. Since these two temperatures are fixed values, so only option for us to increase the value of Q, we are only left with the increase in the value of area. So what is this area I told? It is this surface which is coming in contact with the air. So if we can increase this area, then we can say the heat transfer from the surface to the air will be increased as per the Newton's law of cooling. So here is a point where we will come across an important topic called as extended surfaces. So these extended surfaces are nothing but they are called as fins. So now I hope you got the idea what is a topic that we are trying to understand here. So these are nothing but these are the extended surfaces that we are going to attach to the base surface like this. We are going to attach the extended surfaces to this base surface such that the area available for the convection now with reference to the base surface gets increased by attaching like this. Okay, so if the total area available for heat transfer increases, obviously Q gets increased, knowing the limited value of H and the fixed temperature difference. So this is a point of application where we come across the terms called as fins. So fins are nothing but they are the extended surfaces used for enhancing the rate of heat transfer by convection from a given base surface. So basically we find these applications in IC engines. Okay, so in IC engines it is already known. Basically in two-wheelers you can see at the periphery of the if this is IC engine block, okay, IC engine block, you can see at the periphery of the cylinder the small strips like this have been attached, correct? So on either side the strips have been attached like this. So these all are the extended surfaces. So inside there will be a hot gas, okay, and surrounding there will be air like this. So since the gas temperature is more Tc, I'll write this is T infinity. So since Tc is greater than T infinity, obviously convection occurs through this wall of the cylinder to the air. So gas transfers the energy to the air through this wall. But since we want engine to be cooled, okay, but that means this wall cylinder has to be reduced with the temperature, okay, during the meantime. So in that case heat has to be transferred across this surface at a faster rate. Okay, so in order to do that we attach now, as per this discussion, now we are going to attach the extended surfaces. With the help of these extended surfaces, it is made possible to increase the value of Q. So as the rate of heat transfer increases, so engine gets keep on cooling down. However, this value of Q, if the more value of Q, then it may hamper the performance as well. But leaving apart that, we only discuss about the heat transfer rate. Okay, so here the Q is pertaining to cooling of the engine. So more the heat transfer, engine gets cooled quickly. Okay, so in order to achieve that, we are going to use the extended surfaces called as fins. Okay, so henceforth we are trying to understand what is the importance of fins, what are the different configurations of fins, and how we can analyze the rate of heat transfer through fins. That is what is the next point of discussion I am going to make. Okay, thank you so much. I hope you got the idea about the basics behind the usage of fins. What are fins, why they are used, how important they are. Okay, thank you.